Thank you. So we're going to open our town hall session now, which we can mix up with questions for any speakers who happen to be in the room. I thought I would start off by describing some of the feedback that we got from this group 2 years ago, and based on that feedback, we designed a program called Teachers in Residence. So let me see if I can hook up my laptop here. Okay. Okay, I just put some slides together. Let's see if this works. All right. Play. I'll try to keep this short because I want to get this is really a session where you tell me what we could possibly do to help you. So in 2014, we ran our first Teachers in Residence program here, and we're going to do it again in 2016. This is a summer program. It was generously funded, by Phil Wyatt, who's a local physicist and entrepreneur who has a company called Wyatt Technology based on molecular scale light scattering. That's Phil in the middle there with his sons. Their company's located over on Hollister Avenue across from the Santa Barbara Airport. He funded our program. I'm going to skip the next two slides and come back to it. It's more than two. The goal of the program was or is to reach out to teachers and embed them basically in what's going on here at the KITP. I think we had 4 teachers last summer. We have funding for basically that number. They get offices here. They get embedded in the programs here, treated like any other participant in our long-term programs. The difference is that we try to choose programs that have a tutorial aspect so that the teachers can learn together with other people in the program who are learning. So this restricts the programs that we can use for this purpose to just a small subset, actually. We've run it so that it lasts for 3 weeks. So each teacher comes for a 3-week window. I'm not going to read this. You can read it. Anyway, the idea is not just that it benefits the teachers, but it also benefits the program participants because they get to see excellent high school teachers and see how they operate also. So in 2014, I'll just describe what we did. We had 3 programs running simultaneously, as you can see it on the timeline on the right. We had a Superbugs program, which was a biophysics program related to microbial resistance. We had a program on intense laser fields, and we had a program called Earth 14, also called CIDER. CIDER is an acronym which stands for Consortium of something Deep Earth Research. I don't remember what the I is. So Earth 14, otherwise called Dynamics of Planetary Interiors. Most of the teachers went into that program. The other program, Microbial Strategies for Survival and Evolution, we had 1 teacher go into that program. The application process was very simple. You just have to have 3 years experience. We only require 2 recommendation letters, one from your principal, one from a peer. Most important, I think, was the personal statement and the outreach plan for this. why were you interested in that particular program that you applied for, and what do you want to do with the exposure to that particular field of physics? How will you use it in your ongoing activities? So that's the end of my description. I just in 2016, I think we might restrict the program to just the geophysics program. That is just the program called CIDER. This is a few words about what CIDER was doing in the past. That actually doesn't include 2014 because it's an old slide. But CIDER is a very interesting program. We bring in not just what makes it attractive from our point of view is we bring in not just the senior researchers, but also graduate students. And that's why it was very valuable, because the teachers were in an environment that the graduate students were in also. They were learning from the world's experts. And so it was not like throwing a high school teacher into the midst of, string theorists who speak a special language that no one else can understand, right? There were a lot of people in the program who were learning. So I just show some images from the CIDER program, but the CIDER program is a very rich program because it involves all these areas of geoscience, geophysics, and physics. So, okay, that's the end of my presentation. I'm going to open it up to questions. I think we have 2 microphones. So what I'd like to hear from you is, tell us about what maybe the KITP could do within its purview to help high school physical science teachers. Okay. Thank you. I hope not to say too much. Just listen. Yes, Melinda.
Were there materials that were produced, and if there were,
yes, there are some materials that are yes, there are some materials that have been produced. I've been slow in getting it on the web, so, but I hope to do it pretty soon. Yeah. Yes, Nick.
I was one of the teachers that participated in the program, and it was a tremendous experience for me. I knew very little geology coming into the program, and unlike what Greg said, let me say that it was like expecting to walk into a Geology 101 course and finding yourself in a graduate levels program. It was eye-opening for us, but it was great because the presenters presented just enough physics for us to be able to hang in there. And the really complicated stuff, we were able to talk with them afterwards and straighten things out. As far as producing something afterwards, each of us had the opportunity to produce a different thing. We all had our own separate ideas. The idea I had was to compose a series of modules that any high school physics teacher could use as ancillary materials to any of the subjects in the area of physics they're teaching. For example, I developed a module in geodynamics, which if you're teaching dynamics in your section of physics, you could pull this out and see here's what's going on inside the Earth and here's why. I did one in wave theory, so applying what you've taught your class in wave theory to geoseismic waves and their effects and where they come from and how they are able to actually reach out to the crust and affect us here. I'm currently finishing up my 4th module in the field of geoneutrino production inside the Earth and how it affects the thermodynamic interactions between the core and the mantle and ultimately the crust. And I can present this in a class, say, of we're teaching a unit of nuclear physics. It's something you might want to throw in there. I do teach a modern physics course in my high school, and I'm waiting to try it out, that one particular segment. We get to nuclear physics in about a week or 2, so I'm going to be using them as guinea pigs. It has been a great experience, and they have been wonderful to us. It was tremendous interacting with the scientists and also with the grad students. They took us under their wing, and they really helped us through. The grad students, it was a tremendous experience. We got to have lunch with them every day. It was a series of lectures in the morning, more lectures in the afternoon. There were some computer simulations that were done. It was wonderful to hear the interaction between the scientists, because I would say that they all knew each other. Obviously, they're all working in a field of either geodynamics, geology, mineral physics, geochemistry. So they were all experts in their field, and they had the ability to ask questions as they had them, and there were quite a few very interesting interchanges during the course of the lecture. And we got to sit in on this and hear some of these interactions that were, in some cases, a little bit extreme. Some of them had very strong feelings one way or the other. But they are all great friends. They all knew each other, or they all had read each other's papers, or they all worked together. So it was great being a part of that whole scene. So that's one of the greatest things I got out of it. And talking to my students this year about it, I'm able to convey to them, this is what scientists do when they get together. And they don't all agree with each other. And sometimes to see how they disagree is quite an eye-opening experience.
Yes?
One suggestion, and then perhaps a follow-up question, would be that there's all these wonderful conferences that are archived. The talks are archived. It'd be great to have an access to at least curricular materials that are at least related to those talks or to those conferences. And so the question would be, would that be something that a teacher in residence could engage in? Pick a conference, let's say, or pick a couple of conferences, and develop some curricular materials for high schools?
If I understand well, part of it was a comment and part of it was a question, I guess, but we record everything.
Right.
All of that's recorded.
Right.
It's already there, plus the slides of their talks. It's not just the recording, but the talks appear in different formats, so all the material is already online. But you're asking, I think, something more? Pedagogical material?
Right. So I'm thinking in terms of taking, what the content that's in the talks and developing materials that could use the talk as the basis for the materials, or make materials that that could be used in the broader physics teaching community.
Yeah. Well, that's okay. That's great. I want to hear more about that. That's what you people can do for us, right? I'm not an expert on high school physics teaching. I know nothing about how to approach that level, really. We rely on your expertise to do that translation to your students from the raw materials we produce here. It's your job to assimilate it and convert it into something that you can use in your environment. So, can we make that easier somehow? I'm not sure, but that's the purpose of the program in a sense. Yeah.
Just a kind of a follow-up on that. Maybe if there were a forum whereby, say, if one teacher takes a segment and they do exactly that, come up with a lesson plan to build around it, including maybe some worksheets, lab activity, things like that, a forum where they could post that on the website, then I could grab that and use it. And if I came up with something, I could post that. And that way we could all kind of contribute to...
So an online forum here at the KITP. Are there existing physics education fora, which, that's the plural, which would be a natural host for this, or should we do it on our own website? I'm putting it out there. I don't know the answer.
They did have the Rob presentations.
Yes.
So that they're already up.
Yes, that's correct.
So they could add to that.
Yep. But that's, I mean, they're there, and I think they're used. So they're mostly just PowerPoint slides, not other materials, but Is that true? I don't even know that. Okay. Yeah.
Well, just along this point, you asked the question: is there other natural forum for this? All the forums tend to be more specific to, particular. There's an AP Physics forum for that, and it's to their particular goals and such. Here, I think it would be much more useful to us for you guys to host things based around the talks that are and the materials you guys have online here for us. I mean, I can download any of the videos, show any of the PowerPoints, steal slides, which I do, to incorporate into my presentations to my students. But anything I create, I have no place to put that would have any relevance or any meaning. If I take it and I put it on the AP Physics website, they're like, well, this doesn't really fit into our curriculum, into our plans, into the materials. So that's why I think it would actually be a much better, more natural benefit for you guys to host something based around your talks.
Okay, thank you.
Is it possible to, what John was saying, to take a topic that's not in the earth science, but you've already presented it, and then
I see.
make
Okay.
class curriculum from those topics that you've already archived, I guess? As part of the teacher program.
What's the benefit of having the teachers here then? That could be done anywhere in the world.
Well, they're around experts.
Well, the experts, I'm trying to think this through in real time. So the experts we have are constantly shifting depending on the spectrum of programs we have at that time. So if you're going into the archive, and your interests are in area X, we probably don't have area X represented at that time. That is, the number of permanent people here is like 5 or 6. The building is usually filled with 75 visitors from around the world, as the principal scientist. So the idea of the Teachers in Residence program was to give you personal contact, embed you in real time with the people who are in the building at the time. But what I'm hearing here is a little different. That activity could be done anywhere on the globe based on our archive. Maybe we could look into somehow supporting teachers to do that work, but probably it wouldn't be here in our building just because of our space requirements. Or we're completely saturated now with running our programs, basically. So unless we embed you in a program, we have very little wiggle room in terms of space and other resources here. So that's the logic behind what we've done in 2014 and what we plan to do in 2016. Well, I think I'm getting a clearer view of this idea. Maybe teachers could take resources that already exist and do this translational process in their pajamas, in the privacy of their own homes or something. How would we fund that? I don't know. Would we have to fund it? There's a lot of interesting questions there. So thank you for the idea. Yeah, way in the back.
Yeah, it just seems to me like a lot of the inspiration and a lot of what we're learning occurs on this one day. And rather than having teachers go out and on their own at some point try and develop curricula, what about budgeting a kind of 2-hour workshop, whether it's the Saturday or maybe Sunday morning, in which you get smaller groups of teachers and maybe one visiting professor or someone who gave a talk could be a part of that and just brainstorm some materials And whether that has a product or not, I think that'd be really useful.
Thank you. Yeah, interesting idea.
Is there
yeah.
a timeline for the applications and the weeks that it will be during 2016?
Right now, no, because we haven't even the primary activity hasn't completely been settled in all of its details. So timeline on your, I mean, it will be summer, kind of roughly the dates I showed for 2014. In terms of application materials and that timeline, so we anticipate making decisions. Well, what we did last year is we made decisions in the spring. So that's the first time we did it. Maybe it was a little too late from my point of view. So I think it'd be good to move that up a bit. So I'm thinking application deadline probably February 2016, sometime in February, and then hopefully a decision within a month of that. So, yes.
So as I have used, there's a talk online by Professor Monreal that was here right after the Fukushima disaster, and it's a great background if you don't know much about nuclear isotopes, which I didn't. I knew some, but you can go back and look in these archives, and I've cherry-picked some of the slides and to show my students. And so yes, the talks are online, the slides are online, and it's all really useful. The other thing that we're facing in California, and I know a few other states are, is the next generation science standards. And I was listening to your discussion of geophysics, and I'm thinking that's what we need to do, because they want us to, in many ways, water down the science we do to make somebody happy. But I know that when you come to a university, physics hasn't changed. So how do we get earth science mixed in with physics and still do it at a level that when they get to some place like this as a freshman, they don't get blown away? And if we could do like lessons that you guys did from that, if we could get those and mix those in, that would be perfect.
Well, it's interesting you say science hasn't changed, because of course it is changing. But I know what you mean. I guess a question I would have for you is, what value is this constantly changing mode of physics that we have here to you?
So
you don't just want to teach Galileo era physics, even though that's great. You want to incorporate exciting new ideas. I have taught physics at different levels, and I had big debates with teaching the optics class. Do we start with geometric optics and then move to waves and then blah blah blah, all the way to lasers in the last chapter, which we never got to because we ran out of time? Or do we start with lasers and say, look, hey, there's something called quantum mechanics, and it's exciting, and it's counterintuitive, and it's how the world works, and here's a quantum device. Let's look at it. I was definitely in the latter camp, and some of my colleagues were in the former camp. Oh, you couldn't possibly do that. They know nothing. They don't even know about lenses. How could you do lasers, Well, you have to rethink things maybe, how you usually do it. I don't know. I don't know the answer, but I would push back against this idea that the physics hasn't changed. But yeah, there's a 1 and then 2. How about that? Yeah. And 3. Okay.
I was just going to follow up to I think part of his question. I'm Ryan Strickland. I was a participant of the Teacher in Residence last summer. 2 things that I'm still working on, actually. One was when we were at the talks, a great percentage of the lectures I attended, they kept going back to Hooke's law. That was like the first slide, guaranteed. So I worked on one of the things I'm working on is about Hooke's law, using basically a high school level understanding of Hooke's law to understand more geophysics stuff. So I thought that was a cool way to take cutting edge stuff and make it more approachable at a high school curriculum. So I don't really know if that's what your question was, but okay. Thanks.
Several years ago, I participated in a project to help design materials to train teachers for the new Florida State Sunshine Standards. And it was very eye-opening to me because the teachers were very much constrained, and I fear that if we developed things sort of focused on what we're doing, a lot of it might not integrate in well to what sort of the realities they're facing. At the same time, what I saw was great ideas at the top of what should be done to improve the science curriculum. But by the time it was implemented, it was a complete disaster and worse than before. And so having sort of domain experts in the room who could say, well, actually, no, it's really not that simple, and push back on that a bit, I think can help counterbalance that push to dumb things down to correct answers and binary choices. So perhaps a tweak on this curricular materials, rather than creating new things based around what some expert is saying is currently a controversial topic and is very interesting, perhaps some of you, the teachers, could find lessons that or curricular materials or standards that you need to meet and identify when it intersects with a program or experts who are here, and then maybe approach them about, how would you like to see this change to more accurately reflect the way science really works, the way our current knowledge is. So maybe starting from the other direction, seeing if people can meet in the middle.
Okay, should we take an oath to do no harm? Basically, is that what I'm hearing?
This was the goals of the reform were good goals and the ideas were good, but in implementation, just the various contrasting forces made it very difficult to live up to those ideals. And so that's why this curriculum building is really hard to do well.
Yes, I think we're all in agreement. This is a difficult task. Louise. Oh, by the way, before Louise speaks, I want to thank the coordinators of the Evo Planets program, for which this conference is embedded. And Louise, could you just wave your hand? You're one of them. Eric Ford, who we heard this morning, is the other. And a special thanks to Jeff Marcy, who's seated right behind Louise. Eric's the coordinator who put this meeting together and helped us with the progression of speakers so that we're building up in a ladder from chaos in the early solar system to intelligent life, whatever that means. So in any case, Louise, I'm sorry. Go ahead.
That's okay. So I'm also a participant in the CIDER program that's been discussed as a scientist. I'm a geophysicist at University of California, Davis, and so I've been at multiple of these CIDER programs. So it's actually really great to hear from the teacher participants last year, because it's nice to hear where you took that and where it went. And from our point of view as scientists, it was really marvelous to have high school teachers embedded in the group and in the research groups and in the mix. That was really a positive experience from our point of view. In answer to an earlier question, I think what we would hope is that by using something like geophysics, it doesn't have to be geophysics, but that's where I'm coming from, one can really teach the basic principles of wave propagation, the easiest and heat flow and force balance and so on. The easiest sort of example is seismology, which is essentially wave propagation. And so you can sort of use that as the example, using all of the classical things that you want to convey and teach. But your students will have, especially if they're California students, I don't know if everybody here is from California, or maybe even Oklahoma students, they will have some real direct connection to that, and then that will basically prepare them well for their college physics classes, because they'll have really understood it by pulling these examples from geophysics. So that's really where we're coming from. And I think most of the geophysicists that I know, including myself, our career path is more or less college physics followed by graduate school in geophysics. So most geophysicists were college physics majors before they moved into the earth sciences. So that's the path we took.
Yeah, I'll just add that when you're here at the KITP, you really see the unity of physics to a large extent, and geophysics is an area here that we would really like to, we'd like to increase the participation of geophysicists at the KITP and have more programs related to geophysics and all the other related fields here. Yeah. So anyway, thank you, Louise. And just so you know, teachers here are from all over the United States, not just California, even exotic foreign countries like Canada. Okay. Yeah.
I find the need to do a little plug for a group that I work with. It's called the Contemporary Physics Education Project, and we have 4 posters that are in contemporary products or contemporary physics areas like particles and fusion and nuclear and cosmology. And along with that, we've done a lot of different teacher activities that are on our website, and it's a nonprofit group. But I've been working with them for probably about 13 or 14 years now. Mm-hmm. And while at times we find a standstill in how to get that stuff out to people, we have attended like the American Physical Society meeting and worked with people on fusion physics and done teacher workshops and things like that. And there's so many opportunities to provide things like that and sprinkle them in to regular topics in physics, whether it's magnetism or whether it's electricity. And it can be done very easily and put into the everyday curriculum and still pull out those exciting areas of physics, those places where there is new stuff. So this sounds so awesome to me, to do something in geosciences and be able to expand on a different area. I think there's so much that can be done with that, and I want everybody to realize there's a lot of places you can put it into your regular curriculum and get the kids excited about what's going on.
Great.
So.
Thank you for the comment. Who's next? Yes.
I have 2 comments. One was when I was teaching introductory physics or whatever in high school, I would, especially if I were the only physics teacher, you have a short beginning unit on particle physics using what's the website? The
QuarkNet?
Well, not QuarkNet, but they had the particle
Adventure?
Oh, yeah, Particle Adventure, whatever it's called. Anyway, it was a very descriptive. But I had kids who were bored with engines and bored with velocities, really love physics. They left my class saying, I'm going to do that someday. So I think if you have control at all over what you're teaching, you can make this a short thing or you can make it a 6-week thing. But by introducing these topics, we're really getting some kids excited who would normally find the content boring unless they love the math like I do. And the second thing is, I know there are some retired teachers here and some who will be retired. And I mean, it just ache inside when I think about missing the classroom. But we might be a good source to do some of the putting together materials on, going through the resources. At least we'd feel like we're doing something.
Well, is there an association of retired physics teachers?
I don't know.
Maybe there should be. Maybe that group should self-organize. Okay, we have a few minutes for more questions or comments.
I'm a public school teacher here in California, and we have been released from the shackles of California Science Standards testing. We have.
So
we no longer have yearly testing. Amen.
So can you say a word? Can you say a word?
Yeah. Well, we used to have. You had to be to Z by April 10th.
Yes.
Because on April 15th they were going to test A through Z.
Yes.
So they do give the test to juniors. It's called SBAC, Smart Balance Assessment, and C stands for crazy or some other word that I don't want to say. And it's English and math.
Okay.
And so, but it's a lot of expository writing and analysis, critical thinking, as opposed to fill in the blanks,
Yes.
slap your finger, A, B, C, D, which one hurts more, that's the answer. In my mind, physics is the foundational science for a reason. And, I've found in teaching it, I can apply it to almost anything we want to do.
Mm-hmm.
And so, I can teach geophysics with waves. I mean, that's waves and geophysics go perfectly. But it does a lot. So I think for us, that whoever mentioned, get together and have a little 2-hour meeting. It doesn't have to necessarily be with you guys, but to sit down and talk about the different fields that we work, and then throw out ideas about how you can integrate new and exciting stuff, the new physics, not the dead physics, and to get the same ideas across. And it doesn't necessarily have to be here. We could do it, online forum. I think the real thing was we wanted to have a place where we could collect all this and people could access it. And I think we could do that on our own, like with a wiki or something online or something like that. That's not far-fetched. But to take the fields that we talk about here, try to distill them down into something that my students would be able to comprehend, but by the same time feel how that changes. And I think the whole idea of the debate is good, because what we teach them is like, we say, oh, this happened. Well, by the way, that took 35 years to happen, but now it happened in 40 seconds in class. And so to give them a better idea of the arguments, yes, and the dissent and how that's a good thing.
Yes.
So I think that would be a good starting point for us to do.
Okay, great. Thank you for the comment. I think I'm hearing that from different people, there's no such thing as dead physics. There's only dead applications to physics, which is continually vital to different fields. If that's the end of the... Oh, yes, please.
Do you summarize a whole conference where important ideas come out, and then maybe those ideas could be watered down or made simple enough so high school students could be able to access them?
Well, I guess you'd have to be in the habitable zone to be watered down, right? That's what or have a sufficient overlap with.
There's the newsletter.
So there's which newsletter?
Our newsletter.
So the answer to your question in the most general form is no. There is no. There used to be a newsletter, or I mean, there's occasionally a newsletter. I don't think that's exactly what you're asking for, though. There is one resource I can point you to. So sometimes we have a kind of talk called a Blackboard lunch. Also on our archive, they're all recorded. At the Blackboard lunches, there's always a speaker from a program, and sometimes the speaker decides he or she is going to summarize what went on in that program. Give an overview. It's all on the board, no PowerPoint. That's actually good because it means that the speaker is slowed down and only emphasizes the important points. So I would take a look at some of the Blackboard lunch talks. They're not all of the category that you're asking for. Some of them are an introduction to the field before the program has really gotten underway. Some of them are kind of a miniature topic drawn from that program. Just, I'm going to do a little miniature, I'm going to cover this one subtopic in a nice way on the board. But others are of the form that you're saying, like, what happened in the 12 weeks of our program? What happened here? Or what were the key ideas? Or what are the key ideas in the whole field? So those are nice talks. So I would Google Blackboard lunch talks, and maybe you'll find some gems there. I think time for one more. Yeah.
Yeah, during the years of the Rob Presentation Award, it was 4 years anyway, a number of presentations were handed over to the KITP for assessment, and all you've got to do is get on the KIT website, access Rob Awards, RAAB, and you'll see there are a number of great presentations that were essentially done to summarize what was done during this conference, what was said, and some of the things to come out of it. And these presentations go beyond just the basic summary. Many of them also include exercises and vital questions and things like that can be used by high school physics teachers. And I know there are a couple of Rob Award winners here, but the last one on biology and physics meeting, and we have one on particle physics. We have one on exoplanetary systems, and one on the development, basically, of quantum theory, quantum optics. And there are some great presentations, great slides you can steal. And I think you put in contact with the people that made these presentations. They'd be happy to talk with you about them. But that's one of the things that KITP has done that I think has been really, really great. I wish they would continue that again.
Okay, great. Thanks, everyone, for your comments and questions. We'll go to lunch now. What time do we come back? Anyone have the schedule? 2. Thank you.